Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Step 1. Reaction of benzene with cyclohexene under H2SO4 heat. Friedel-Crafts alkylation. Cyclohexene is protonated by H2SO4 to give a cyclohexyl carbocation or allylic carbocation via hydride shift. Electrophilic aromatic substitution of benzene gives 1-phenylcyclohexane, A. The double bond remains in the ring adjacent to the phenyl-bearing carbon, giving 1-phenylcyclohex, 1-Na, or the most stable alkylbenzene with the double bond conjugated adjacent to the ring. Actually, under acidic conditions, benzene undergoes Friedel-Crafts with the cyclohexyl cation, but since cyclohexene can form a tertiary-like allylic cation, the product A is 1-phenylcyclohexane, cyclohexene with phenyl at C1, i.e., the double bond at C1, C2. Step 2. NBS followed by ALC. KOH, NBS performs allylic bromination of 1-phenylcyclohexane. The allylic position adjacent to the double bond is brominated. Alcoholic KOH then causes dehydrohalogenation, E2 elimination, generating a new double bond. Starting from 1-phenylcyclohexane, double bond C1 is equal to C2, allylic bromination occurs at C3, allylic to C2, giving 3-bromo-1-phenylcyclohex, 1-Na. Alcoholic KOH eliminates HBr to give 1-phenylcyclohex, 1,3-diene or shifts the double bond. More precisely, elimination from C3Br with the adjacent C2H gives the conjugated diene, or elimination towards C4 gives 1-phenylcyclohex, 2-Na, shifting double bond. The net result of NBS-ALC.KOH on 1-phenylcyclohexane is to give 3-phenylcyclohexane, double bond shifted, or 1-phenylcyclohex, 2-Na. The key product B is 1-phenylcyclohex, 2-Na, which has the double bond at C2, C3 and phenyl at C1. This corresponds to option B. Description: a cyclohexene ring with pH at C1 and a double bond, ready for epoxidation. Step 3. RCO3H, peracid, epoxidation. A peracid converts the double bond in B to an epoxide via S-ion addition, concerted mechanism, giving the corresponding epoxide C. The double bond in 1-phenylcyclohex, 2-Na, B, is epoxidized to give 1-phenyl, 2,3-epoxycyclohexane. This matches option B. A cyclohexane ring bearing a pH group at C1 and an epoxide at C2, C3. Why other options fail? Option A shows an epoxide with pH at C4 not consistent with the reaction sequence. Option C shows a diol, a peracid gives an epoxide, not a diol directly. Option D shows a fused benzene cyclohexane epoxide, tetrylen epoxide, which would require intramolecular cyclization not described here. Therefore, the correct answer is B. Therefore, the correct answer is option B.